Welcome to this video lecture series. Today we will going to discuss about on topic is heat transfer applied to aerospace engineering in rocket thrust chamber. And a rocket thrust chamber is a critical part of a rocket engine where the fuel combustion occurs to produce thrust. It is essentially the area in the engine where the fuel and the oxidizer are injected, mixed, and burned to produce high pressure and high temperature gases. These gases are then accelerated and ejected out of the nozzle to create the thrust that propels the rocket forward. The key components is the combustion chamber, injector, cooling jacket, nozzle, throat, and exhaust. And the rocket thrust chamber, the combustion chamber is the heart of the thrust chamber, where fuel and an oxidizer are mixed and burned. This combustion generates extremely hot, high pressure gases. The chamber is typically made from materials that can withstand high temperatures and pressure, such as special alloys or ceramics. Injector. The injector is located at the top of the combustion chamber and is responsible for introducing the fuel and oxidizer into the chamber in a way that ensures efficient mixing and combustion. There are various types of injectors designed to optimize the mixing and maximize the energy release from the fuel. So, cooling jacket. The combustion process extremes heat. The chamber must be cooled to prevent it from melting. This is often achieved with regenerative cooling, where the fuel or another coolant is circulated around the chamber before being injected, absorbing the heat and keeping the chamber temperature within safe limits. Attached to the combustion chamber is the nozzle, which converts the high pressure gases into high velocity gases, directing them out of the rocket to generate thrust. The nozzle is typically a bell-shaped structure that helps accelerate the exhaust gases. It works on the principle of expanding gases, using the difference between the pressure in the combustion chamber and the outside pressure to create thrust. Throat. The throat is the narrowest part of the nozzle, where the gas reaches sonic speeds. As the gas passes through the throat and into the division section of the nozzle, it accelerates to supersonic speeds, further increasing the thrust. The high speed, high temperature gases exit through the nozzle as exhaust. This expulsion of mass at a high velocity in one direction generates thrust in the opposite direction, according to Newton's third law of motion. And how the thrust chamber works. Fuel and oxidizer injection. Fuel and oxidizer are injected into the combustion chamber through an injector. These are mixed thoroughly to ensure efficient burning. Combustion. The fuel and the oxidizer ignite in the combustion chamber, producing extremely hot, high-pressure gases. This reaction releases the energy that propels the rocket. And gas acceleration, the high-pressure gases are forced through a narrow section called the throat of the nozzle, where they reach the speed of sound. And nozzle expansion. As the gases pass through the nozzle, they expand and accelerate to supersonic speed, converting pressure energy into kinetic energy. Thrust generation. The high-speed exhaust gases are ejected from the nozzle, creating thrust in the opposite direction, according to Newton's third law, pushing the rocket forward. In summary, the thrust chamber burns fuel to generate high-energy gases, which are accelerated and directed out of the nozzle to produce thrust that propels the rocket. So, this is the summarized section part of rocket thrust chamber in aerospace engineering is relevant to heat transfer. These images is applicable about the combustion chamber, injector, cooling jacket, nozzle, throat, and exhaust. And this image will explain about the rocket combustion chamber. And this is the rocket thrust chamber and its types. Thank you.